We think we know intelligence when we see it. You know, that spark, that quick thinking, maybe just getting the right answer when no one else does.
Right. It feels obvious sometimes.
But the moment you actually try to pin it down, try to define it universally, the whole concept just sort of explodes. It gets really messy really fast.
You have fragments.
So today we're doing a deep dive into exactly that mess. We've got a stack of sources here that look at intelligence not just as, a human thing, a mental trait,
Hmm.
but as something you find across all sorts of living systems and even machines now.
It's a really broad spectrum we're looking at.
Absolutely. And our mission really is to try and distill all these different ways people have tried to define intelligence. I mean, going way back to the Latin root intelligere.
Which means to comprehend or perceive.
Exactly. All the way up to like the complex math they're using to build AI today.
And it's crucial right at the start to get a handle on just how slippery this topic really is. Our sources often point back to this big consensus report.
Oh, yeah, the APA one from 95.
That's the one. The American Psychological Association. They got together, what was it, 24 really prominent theorists on intelligence?
Yeah, the top people in the field at the time.
And basically got 24 different definitions back, often conflicting. It just shows it's this incredibly complex set of phenomena. There's no single definition everyone just agrees on. People emphasize different aspects.
Okay, so given that complexity, that lack of consensus, maybe we need a kind of baseline, a working definition just to get us started.
That's a good idea.
What's the core idea, the sort of functional thread that links these definitions together, whether we're talking about Einstein or, I don't know, an octopus?
Well, okay, if you boil it down, that core function usually involves maybe three key things. First, the ability to perceive or infer information from your surroundings, from the environment.
Okay, perception. Got it.
Second, the capacity to hold on to that information,
Mhm.
retain it as knowledge.
Memory, essentially.
Right. And then, maybe most crucially, the ability to apply that knowledge, to use it for adaptive behaviors within whatever context you're in.
So perceive, retain, apply.
Exactly. At its heart, it's really about adapting successfully, especially when things change, when you face new circumstances.
Okay, that makes sense as a foundation. Let's start by unpacking the human side then, because historically that's where most of the focus has been, right?
For sure. That's the traditional starting point.
And when we talk about human intelligence, the scope is just. It's enormous. Our sources list things like abstraction, logic, self-awareness, learning, obviously, emotional knowledge,
Reasoning, planning, creativity.
critical thinking, problem solving. Like you said, a huge range.
Yeah.
An intellectual Swiss Army knife, almost.
That's a good way to put it. And using that framework we just talked about, the adaptive one, it's really important to draw a distinction early on between intelligence itself and learning. Intelligence is more like the cognitive capacity, the underlying potential you have.
Okay, the hardware, maybe?
Sort of, yeah. Whereas learning is the act of actually acquiring and retaining facts or skills. It's the software you install, if you like.
So you could have, theoretically, high intelligence, great hardware, but not much learned knowledge yet.
Exactly. Or, the opposite. Someone might have learned a lot of facts, but perhaps lack the deeper capacity to apply them flexibly. The capacity, the intelligence, is seen as more primary.
Right. So to make that capacity less abstract, let's look at some of the specific academic definitions that came up in the research. Alfred Binet, for instance, he was working in the early 20th century,
Okay, in France.
trying to figure out which kids might struggle in school, right?
Yeah.
His focus seemed really practical.
Very practical. Binet was all about real-world function, especially in the classroom. He defined intelligence by looking at things like judgment, good sense, and crucially, the faculty of adapting oneself to circumstances.
So for him, it was very functional. Can this child adapt to the specific circumstance of school?
Pretty much, yeah. Does the child have the judgment and adaptability needed for academic learning?
Then later you get David Wechsler. He developed the intelligence scales that most people, if they've heard of IQ tests, are probably familiar with. His definition sounds broader.
It does. Wechsler talked about the aggregate or global capacity of the individual to act purposefully, to think rationally, and to deal effectively with his environment.
Global capacity. That sounds less like just school screening and more like, I don't know, overall competence in life.
Yeah, it suggests a more comprehensive ability to navigate the world effectively.
Yeah.
Acting purposefully, thinking rationally. It's bigger than just academics.
But then you've got someone like Howard Gardner coming at it later still, who seems to add another layer.
He really did. Gardner took a more proactive view, maybe. For him, intellectual competence wasn't just about solving problems that are already there.
Right.
He included the potential for finding or even creating new problems to solve. That's a key addition.
That's fascinating. So if Binet and Wessler were more about adapting to the environment or functioning within it, Gardner sees intelligence as having the potential to actually change the environment by identifying new challenges.
That's a great way to summarize the progression, yeah.
Yeah.
It raises that fundamental question. Is intelligence about the scope of your abilities? Is it about how well you function? Or is it about the impact, the output, the changes you make?
And I guess the attempt to measure that scope and function leads us straight into the most, well, powerful, but also maybe the most controversial tool in this whole field, the IQ test.
Absolutely. The intelligence quotient. It started, like you said, with Binet, as a way to identify potential learning difficulties.
Right, for
But
support.
it very quickly became this pervasive tool used for all sorts of things.
Mm.
Military assignments, screening immigrants, job applications. Its use exploded.
And the statistical idea that really gave the IQ test its weight, its influence, was the concept of the G factor, general intelligence.
Right, G. And it's important to understand what G is and isn't. It's not, a physical part of your brain or some single specific mechanism we can point to.
Okay, so what is it?
It's a statistical construct, a very powerful one. It comes from observing that people's scores across a wide range of different cognitive tests, verbal tests, spatial reasoning, quantitative problems, memory tasks, tend to be positively correlated.
Meaning if you score well on one type, you're likely to score well on the others too.
Generally, yes, there's a positive correlation, and G is the statistical factor derived from those correlations. It represents the variance that's common across all those diverse cognitive tasks. It suggests there might be some single underlying mental capacity influencing performance across the board.
So the idea is if you're good at, say, solving abstract puzzles, you're also probably pretty good at understanding verbal analogies because both tasks tap into this deeper well of general cognitive ability, this G factor.
That's the core idea behind it, yes.
But you mentioned controversy earlier. Where does that come in?
Well, the controversy really revolves around its scope and its interpretation. I mean, most psychologists would agree that IQ tests, especially those designed to measure G, do reliably measure something important.
Okay.
They measure a specific and often crucial dimension of intelligence, particularly the kind of intelligence that predicts success in, say, academic settings or in tasks requiring abstract, logical thinking within structured environments.
So good for predicting school performance, maybe certain jobs.
Often, yes.
Yes.
But, and this is the big but, many psychologists seriously question whether an IQ score captures the entirety of what we mean by intelligence. Does it measure intelligence as a whole?
Because life isn't a standardized test.
Exactly. The real world is messy, unpredictable, and requires a lot more than just abstract reasoning. So relying solely on IQ might give you a very narrow picture.
That actually leads us perfectly into the next area. If IQ tests measure the specific cognitive slice well, but maybe not the whole pie, what other dimensions do our sources say are vital for succeeding out there in the messiness? Is this where things like emotional intelligence fit in?
Precisely.
Yeah.
Yeah. Once you move beyond pure cognitive processing, like what IQ tests focus on, you have to consider other abilities that are critical for real-world success. And emotional intelligence, or EQ, is a big one.
What does that involve exactly?
EQ is generally seen as the ability to accurately perceive and understand the emotions of other people.
Okay, reading the room.
Reading the room, yeah, but also conveying your own emotions in a way others can understand. And perhaps most critically, it involves managing your own emotional state effectively.
Managing your own feelings. How does that relate to intelligence?
Well, the idea is that if you can manage your own emotions, not get overwhelmed by anger or anxiety, for example, you're better positioned to think clearly, make rational decisions, and solve problems effectively, especially under pressure. So it directly benefits your cognitive functioning.
I see. And then closely related to that, but maybe more focused outward, is social intelligence.
Right. Social intelligence, or SI. This is more about your capacity to understand the dynamics of social situations, picking up on subtle cues like body language, tone of voice.
Things not explicitly said.
Exactly. And understanding the motivations of others, and even your own motivations within those social interactions. It's about navigating the complexity of interpersonal relationships smoothly.
So how is that different from EQ? They sound quite similar.
They are related, definitely. Some theorists even debate if they're truly distinct. But generally, you could think of EQ as being more about your internal emotional world and your ability to manage it and express it. SI is more about understanding and navigating the external social world.
Okay, so you could theoretically have high EQ, be very aware of your own feelings and manage them well, but still maybe miss important social cues or misread a situation if your SI is lower.
That's the idea, yeah. One focuses inward, the other outward, though they obviously interact a lot.
All right. And then climbing maybe another level higher, our sources talk about moral intelligence. And they seem to emphasize that this one is distinct from both EQ and cognitive intelligence.
That's right. Moral intelligence is presented as a separate capacity. It's defined as the ability to understand right from wrong, to grasp ethical principles.
The knowing part.
Yes, but crucially, it also involves behaving based on the values you believe are correct. It's not just knowing the difference, but acting on it.
And why is it considered so distinct?
Because you can imagine someone who is highly intelligent in the cognitive sense, high IQ, and maybe even has high EQ, meaning they're brilliant at understanding and even manipulating others' emotions.
Like a very effective con artist.
Exactly. That person could still be, morally bankrupt. Moral intelligence requires integrating those cognitive and emotional skills with the consistent application of abstract ethical values to guide your actual behavior in the world. It's a different kind of computation, if you will.
These different types, emotional, social, moral, Terry, they really seem to highlight that classic split people talk about. Book smarts versus street smarts.
Oh, absolutely.
Yeah.
That dichotomy captures it perfectly. It reflects the different kinds of knowledge and application we value in different contexts.
There was a quote about that.
Yeah, the AI researcher Hector Levesque pointed this out. He noted how book knowledge, the kind you get from school or formal learning, is sometimes looked down on, almost derided in certain circles.
Right, seen as impractical sometimes.
Whereas knowledge acquired through direct experience, the kind you get from actually doing things, navigating real-world challenges, that's often highly valued as street smarts.
So it's that difference again between just accumulating information like in a book.
And actually applying it sensibly to solve an immediate, practical problem, maybe even a survival problem. That's street smarts.
That contrast is really useful. The difference between abstract, maybe codified knowledge and that practical real-time application, it feels like a great bridge to move beyond just the human mind. Because if street smarts means sensible application in the moment, that sounds a lot like, say, what a clever animal does, doesn't it? Like a crow figuring out a complex puzzle to get food.
Exactly. It forces the question, is intelligence really limited to humans? Or even just primates?
And the answer from the field of animal cognition seems to be a resounding no.
Absolutely not. We're seeing evidence of sophisticated intelligence across species with incredibly diverse nervous systems. Researchers are measuring animal smarts by looking at their problem-solving skills, their abilities with numbers, even a kind of verbal reasoning in some cases.
And the list keeps growing, doesn't it? It's not just the usual suspects like chimps or bonobos, like Kanzi, the ape who learned language.
Right.
We're now seriously studying intelligence in dolphins, elephants, many kinds of birds like parrots and ravens, even rats. And then the really surprising ones like the octopus.
Oh, the octopus is just fascinating from an intelligence perspective. They are so evolutionarily distant from us. What is it, like 500 million years of separate evolution?
Yeah. A huge gap.
And their whole nervous system is radically different. It's decentralized. They have central brains, sure, but also these sort of mini brains in each of their 8 arms.
Wild.
Totally. Yet, despite this completely different biological setup, they show remarkable intelligence, complex problem solving, incredible camouflage that adapts instantly, even evidence of tool use and play. It's mind-boggling.
It really challenges our assumptions about what kind of hardware intelligence requires.
It absolutely does. The fact that high levels of adaptive intelligence can emerge through such different evolutionary pathways is one of the most profound findings in the field.
And maybe even more profound. That statistical idea we talked about earlier, the G factor, the general intelligence factor. Turns out it's not just a human thing either.
That's the really astonishing part, yes. Studies are finding evidence for a G factor in non-human animals, too.
Seriously? How does that work?
Well, similar statistical methods are used. You test individual animals across a range of different cognitive tasks relevant to their species, and you find similar patterns of positive correlation between performance on those tasks.
Wow.
For instance, studies show this general factor accounts for about 47% of the individual differences in cognitive scores among primates.
Okay, that's significant.
But even more startling, maybe, is that similar studies in mice found G explained between 55% and 60% of the variance in their cognitive performance.
That much in mice.
Yep. And what's really interesting is that percentage range.
Hmm.
It's actually very similar to the accepted value for humans, which typically falls somewhere between 40% and 50%.
So the underlying statistical structure of intelligence looks surprisingly similar across humans, primates, even rodents.
That's the implication. It suggests that general intelligence isn't some unique pinnacle achieved only by humans, but perhaps a much more fundamental, widespread evolutionary trait, something that's been optimized again and again for survival across many different lineages.
Okay, if animals possess this kind of general intelligence, we have to address the next frontier, which is even more controversial: plant intelligence.
Ah, yes, the plant debate. This is where things get really tricky, definition-wise.
Because plants obviously don't have brains or nervous systems in the way animals do.
Exactly. That's the main stumbling block for many. The traditional definition of intelligence is so tied to neurons and central processing.
So what's the argument for plant intelligence then? It must be based on behavior, right?
It's entirely based on their sophisticated functional behavior. Proponents point out that plants demonstrably sense their environment, both externally and internally. They build models of that environment.
How do they model it?
Well, they track things like light availability, nutrient gradients in the soil, water levels, even the presence of competitors or pests. And based on that sensory information, they make decisions. They adjust their morphology, like where to grow roots or leaves, and their physiology to maximize their chances of survival and reproduction.
So they allocate resources strategically.
Highly strategically. They engage in really complex resource allocation, weighing costs and benefits. For example, deciding whether to invest energy in growing deeper roots to find water versus growing more leaves for photosynthesis.
But the big counterargument has always been memory, right? That intelligence requires creating and using persistent memories, which needs a nervous system.
That's the traditional view. But even that is being challenged by some of the sources. There's evidence suggesting plants can discriminate between positive and negative past experiences.
Like what?
Like they can learn or register memories about, say, which direction light reliably comes from or where nutrient patches were previously found. Or they might remember past attacks by herbivores and prime their defenses accordingly.
So a form of memory, even without neurons.
A form of biological memory and learning, yes. They demonstrate sophisticated cost-benefit analysis based on past experience and current sensing. So, while they lack the structures we associate with intelligence in animals, their adaptive behavior is remarkably complex and, some argue, intelligent in its own right.
It really pushes the boundaries of the definition. Okay, from the controversial world of plants to the domain that's dominating headlines everywhere: artificial intelligence.
AI, the final frontier for now.
And the goal here seems pretty straightforward, at least on the surface. Just create machines that demonstrate intelligence.
That's the ambition. In AI terms, we often talk about an intelligent agent.
What's that?
An intelligent agent is basically defined as any system that can perceive its environment
Okay, sensing again.
and then take actions within that environment that maximize its chances of achieving some predefined goal or success metric.
Perceive, act, succeed. Seems simple enough.
There's a slightly more formal definition that Kaplan and Heinlein use, which captures the modern machine learning aspect quite well. They define AI as a system's ability to correctly interpret external data, learn from that data, and then use those learnings to achieve specific goals and tasks through flexible adaptation.
Learning and adapting are key there.
Absolutely. It's not just pre-programmed responses. It's about learning and improving over time.
And fundamentally, this ability, especially in powerful AI systems, is often described using a specific concept: optimization power. I saw that mentioned by Ollie Hegstrom.
Exactly. Optimization power is a really useful lens. It's the capacity of a system to efficiently steer the future towards states that align with its programmed preferences or goals.
Can you give an example?
Think back to Deep Blue, the IBM computer that beat Garry Kasparov at chess in the 90s. Deep Blue's intelligence wasn't about understanding chess strategy in a human way or feeling the thrill of competition. Its intelligence was purely its immense optimization power. Its ability to calculate millions of moves ahead and efficiently steer the future state of the chessboard into a winning configuration, a subspace of possibilities where Kasparov couldn't escape. It overrode Kasparov's own attempts to steer the future.
That's incredible computational power, incredible optimization. But despite that power, the sources also emphasize that current AI systems still fall way short of humans in one crucial area: general intelligence.
That's the key limitation right now, yes. AIs can be superhuman in narrow tasks they're trained for, like chess or Go or protein folding
Or generating text like ChatGPT.
or generating incredibly fluent text. But they lack the general capacity that humans, and maybe some animals have, to flexibly learn and adapt across a huge range of different tasks, especially tasks they weren't specifically trained on. They can't easily pivot.
And the sources dig into some specific shortcomings that explain this gap, right? What are the main ones?
Well, a primary one seems to be a fundamental lack of common sense reasoning, real-world understanding.
How does that show up?
There was one interesting finding highlighted where models like ChatGPT could actually score very highly on a standard verbal IQ test.
Really? They aced it.
Pretty much, yeah. Because those tests often rely on recognizing patterns in language and information, which these large language models are brilliant at, having processed vast amounts of text data. But when given tasks that required what the researchers called real human-like reasoning, understanding physical cause and effect, or navigating social nuances, basically applying common sense about how the world works, they failed spectacularly.
So they have the book smarts, maybe, from pattern matching the entire internet.
But none of the street smarts, none of the intuitive, embodied understanding of reality. It's calculation without true comprehension.
Which sounds incredibly limiting if you want these systems to interact safely and effectively with the real physical world.
It leads directly to this problem that researchers sometimes call the autistic savant analogy for AI.
Why that comparison?
Because, like a savant, these AIs can possess truly extraordinary skills in very specific, narrow domains: language fluency, image recognition, complex optimization. But they often lack the generalist understanding, the common sense that integrates everything.
And that leads to mistakes.
It makes them liable to take instructions hyperliterally. They might provide precisely what was asked for based on the statistical patterns in their training data, but completely miss what was actually wanted by the human because they don't grasp the underlying context or intent.
They can't read between the lines.
Not in a deep common sense way, no. If the common sense isn't explicitly encoded in the vast data they trained on, they're lost.
And if they lack that fundamental common sense, how do engineers even start to program real-world context or intent into these systems? Is it even possible with the current architectures, like large language models?
That is the multi-billion-dollar question right now. It's a huge challenge. This lack of common sense, this brittleness, leads to another major stumbling block the sources highlight: the problem of disambiguation.
Disambiguation, meaning figuring out what things mean when they could mean multiple things.
Exactly. Natural human language is incredibly ambiguous. Think about pronouns. The pronoun disambiguation problem, or PDP, is often used as a kind of litmus test.
Give me an example.
Okay, take a sentence like, the trophy wouldn't fit in the brown suitcase because it was too big.
Okay. It refers to the trophy.
Right. Now, the trophy wouldn't fit in the brown suitcase because it was too small.
Now it refers to the suitcase.
Exactly. For a human, using common sense about physical objects and fitting things into containers, that's effortless, instantaneous. But for an AI that lacks that real-world grounding,
It just sees the sentence structure, which is identical.
precisely, it has to rely on statistical analysis, of which interpretation is more common in its training data, but doesn't understand why one makes physical sense and the other doesn't. Sentences can be ambiguous in multiple ways simultaneously and without common sense. Navigating that becomes an almost insuperable problem for current AI.
Wow. So this deep dive has really taken us on quite a journey. We started with just trying to grasp the basic idea, the philosophical roots of intelligence as comprehension. Then we saw the attempts to quantify it, like with IQ and the G factor and the controversies around that.
Right, the measurement challenge.
Then we had to broaden the picture, bringing in crucial skills like emotional, social, even moral intelligence, realizing it's not just about raw cognition.
The softer but essential skills.
And then we found these surprising echoes, maybe even core components of intelligence out there in the natural world, sophisticated behaviors in animals with vastly different brains, like ravens and octopuses.
And even the debate around plants and their adaptive strategies.
Right, from ravens to roots. And finally, we landed on artificial intelligence, seeing it as this powerful optimization engine, but one that currently lacks the general understanding, the common sense that seems so fundamental to human and perhaps even animal intelligence.
It's a huge landscape. And reflecting on this whole discussion really brings us back to that question of what might make human intelligence unique, or at least distinct. There's that idea, Dyson's law.
Oh yeah, Freeman Dyson. What was it again?
He basically said any system simple enough to be understandable will not be complicated enough to behave intelligently, while any system complicated enough to behave intelligently will be too complicated to understand.
So, true intelligence, by its very nature, might have to be somewhat incomprehensible even to its creators, like our own minds.
Perhaps, and maybe that necessary complexity, for us at least, comes directly from our lived experience, from being embodied.
Embodied, meaning having a physical body in the world.
Exactly. If genuine agency, real reasoning, maybe even purpose emerges from acting in the physical and social world, from experiencing the consequences, suffering failure, adapting, learning from mistakes, feeling success,
The whole messy process.
the whole messy process. If that's where deep understanding comes from, then what about these AI systems? They are, as some sources put it, essentially disembodied. They are strangers to blood, sweat, and tears.
Calculation without consequence, in a way.
In a fundamental way, yes. So the final thought to maybe leave you with is this. Does the irreducible complexity of our embodied human experience, the feeling, the failing, the adapting within a physical reality, ensure that our intelligence will always remain fundamentally distinct from the kind of optimization power we're currently building in machines?
Is having a body experiencing the world directly a prerequisite for the kind of general, adaptable, common sense intelligence we possess?
That's something definitely worth mulling over. Does intelligence truly require embodiment?